Yeah.
Okay. Good afternoon, from department from Navrachana University. And today we have gathered over here to listen about deep learning, machine learning, and artificial intelligence. So we all are over here to learn something about these three booming areas nowadays, and we have a great speaker. He is also a faculty from Computer Science and Engineering Department from Navrachana University, Mr. Bassar Patel.
So before I start my session, let me give you a small disclaimer about this session. That the key conclusion of this disclaimer is that I have my own copyrights for the way of presentation, and I taken care for the authentication and for the availability of all the materials, all the contents of this session. If there is some error, it must be checked and corrected before taking any kind of action. So basically, before I start, I would like to give you a quick outline of my today's session. So I will start my session with a concept of artificial intelligence. I will give you a quick overview of artificial intelligence, what is the artificial intelligence and how it is applying. And I will go a subset of the artificial intelligence, machine learning in little bit more deeper, and we will discuss about different concept of machine learning algorithm, and then we will go a little bit more deeper for the concepts of the deep learning, that how we can replicate a functionality of a human brain, how scientists or engineers are replicating the functionality of a human brain. And I will share one secret answer for the question of the numerical science, that you will get a 80% probability of correct answer if you give that answer for the any kind of question regarding numerical science or brain science. And then we will deeply discuss the application of the machine learning, deep learning, and computer vision applications. And I will share some of my research, some of my publications, and some of the results of my previous experience with MLDL concepts. And then there are two sessions which I am not disclosing at the moment, which are the very curious and very interesting sessions, having 10 minutes of the time. So total I will take around 1.5 of half hour of your time, and hope you guys love this session. So it is said that tell me and I forgot, teach me and I remember, involve me and I learn. This is a famous quote by the Benjamin Franklin. So today's session will not something like that. I will speak and I will discuss about the things, but your involvement is also important for us. So let us begin with a small introduction of yours, that if you are from outside the Navrachana University, then give a quick answer in a chat box, that where are you from and what you expect, that what topics or what kind of things should I cover in next slides. So I will try to cover that your expectation, and I will try my best to cover your queries. The chat box is open for all the time, so if you have any kind of query, you can write in a chat box. So keep writing in the chat box, and I will check your queries and your feedbacks for that. So what is artificial intelligence? So in today's world, we are more focused on the robotics, we are more focused on the automation, and the artificial intelligence is the things which we require. So AI is the artificial intelligence, where we are trying to mimic the human brain. We are trying to replicate the ability or intelligence of a human. So let's quickly define in the terms of the theoretical word, that artificial intelligence is the ability of a digital computer or a computer controlled robot to perform the tasks commonly as with the intelligent beings. So in a AI, we are using the intelligence to we are giving intelligence to robots and computers to do some intelligence tasks, and the computer process include the learning, reasoning, and self-correction. So these are the three key component of as a human brain, that we learn, we reason, and we self-correct whenever we require. So we are trying to give the same ability to the computers, and the virtual person assistants like Amazon's Alexa, Apple Siri, etc. are the example of artificial intelligence, and these are the common AI tools we are currently using in our smartphones, in a form of Alexa or in a form of Hello Google or a Siri. So we'll give you a quick overview of these things in the next slide, that how we are trying to create the AI things and machine learning things for the smartphone and computers and other electronic devices. So the artificial intelligence is divided into the many landscapes. So if we say that the artificial intelligence is involved with machine learning is directly involved with a lot of data, and with the help of data, we are giving the data to the machine, and it will give you it will learn something from the data, and it will give us the answer from the data. And constraint and control theory are there, so how we can control the robots, how we can control the automation process will be there. Then search and optimization, right? We have a lot of data, and now AI will help you to the search and optimize data and find the conclusion and key things from the available data. Reasoning is also a part of AI, where we do a lot of reasoning. We will solve a lot of problems using the AI, which is a little bit difficult to solve by human, or it is a little bit difficult to solve by the traditional programming concept. Then there is one key aspect of AI is NLP, natural language processing. So in NLP, we are doing machine translation, like we use Google Translate or Microsoft Translate, or text to speech, speech to text, and a lot of things that involves neural language processing. And the last and the most discussed aspect of machine learning in this session will be the computer vision, as I personally have a interest in a computer vision, and my expertise is with machine learning and deep learning with a computer vision. So don't worry if you think that this is a workshop of computer vision. So I will discuss a lot of things, a lot of recent trends in this particular area. So I will one by one, I will go through this different aspect of machine learning, and then we will directly focus on the computer vision types of problem of artificial intelligence. So there are three key terms I used from the beginning, that artificial intelligence, machine learning, and deep learning. So artificial intelligence is the mother of this all things, and it is defined as any technique that enable computer to mimic human intelligence and using the logic, or it can be a traditional programming like a if-then rules or a decision trees, or the machine learning including the deep learning. So in artificial intelligence, we can include the traditional programming methods also. Now, machine learning is a subset of the artificial intelligence, and machine learning is a subset of AI that include abstract statistical techniques. Here we use a lot of maths, a lot of statistics, and it enables machine to improve at a task with experience, and the category includes the deep learning. So here in machine learning, we use a lot of data, and we play with some statistical techniques to learn to create AI. And the deep learning is a subset of the machine learning, and it is a composed of the algorithm that permits software to train itself to perform over the task like speech, image, video, audio, and so many things. And by exposing a multi-layered neural network, the term neural network is something like brain. The fundamental component of a brain is a neuron, and the neural network is a technique to replicate the functionality of a brain. So we will narrow down our session one by one to these three different aspects of artificial intelligence. So let us start with the machine learning. That what is the machine learning? So the my students always give me the feedback that machine learning is nothing, but it is a combination of a algorithm and maths. And someone sent me this meme on social media that this is the machine learning. But jokes apart, machine learning is an application of artificial intelligence that provides the system to ability to automatically learn and improve from the experience and without being explicitly programming. So here traditional programming will use minimum, and we will use the data to uh, to create AI. So as a human, we learn from the experience, and in a machine learning, a machine learn from the data. And in a traditional learning, or in a traditional programming, the machine will learn from the instruction, whatever instruction we give uh, to the program, or in the while creating the software or program, the machine directly follow the instruction. So machine learning learn from the data. And then there is a term data science evolved, because to give a lot of data to the machine, we have to collect the data, we have to process the data, and we have to store the data. So there is a one more term is popular nowadays, which is known as a cloud computing, where we process and store a lot of data to the cloud. So typically, machine learning process, or machine learning is involved with five different steps. So the learning process of machine and human is quite similar, or you can say we are directly replicating the learning process of a human, and we are directly implementing that process of a human to the machines. So in the machine learning, first we collect the data, and we collect the data from the various sources. The data can be in the form of the text, a form of the image, a form of the Excel file, Word file, doc file, and speech, video, audio, or experience. And then we clean and prepare and manipulate data. We will remove the data which is not much useful for our application, or we will prepare the data for the application, according to our application, according to our end results. And we will train the model. So training means that in a model, whatever we create, whatever program we create for the with the help of machine learning, so to that program we will give this input, and this data input will be trained, and it generate a model which will be the learning outcome of this machine learning process. And after the learning of a machine, we will test the data that if the learning is correct or not. This is a similar kind of the examination process, where we ask the students that after the teaching them, we will ask them that we will check that they learned correctly or not. And And in the last process, we will give a feedback, we will share the grades and improve. So similarly in machine learning process, concept of machine learning involves the three tasks. So learning in a machine learning is improving with the experience at some task. And we define three terms that T is improve over task. What is over task is here. And with respect to the performance measure, what is the outcome? What is the results? Which will be over P, and over experience or past experience or learning is defined as a E. So, for example, spam filtering is a classical example of machine learning. Uh, we all have emails, and our email service provider, Gmail, AOL, or Hotmail, or Outlook will classify our emails on the spam and a non-spam. So the spam emails are the irrelevant or unsolicited messages which are sent over the internet and for purpose of the advertising, phishing, or spreading malware. So here I want to classify my email mailbox that the received email is a spam or a not spam. So make a guess that can you define the task, that what is the task here, what is the experience here, and what can be the performance measure for this classical example. Give it a try. Try to give answer in a chat box. Okay, so in this example, task is that identify whether the email is a spam or it is not a spam. And here the experience is a database of email that were labeled by users as a spam or a ham. So this is a past experience. This is a data from the past experience that this type of emails are the spam. For example, which is offering you donation, which is offering you lottery, which is offering you something at a cheap price. It can be labeled as a spam. And the performance is a percentage of the spam emails filtered divided by the percentage of spam emails that were incorrectly filtered. Means that were not a spam, but our system labeled it as a spam, or our algorithm misclassified or received the emails. Hope your concept of these three parts are clear, as these things are quite important for the next upcoming things. So now you have a question that how does the machine learn, how they learn. So machine learning algorithms learns from the data, and they find the relationship, they develop the understanding between the data, they make decision using the training data, whatever data we are giving. Let's take an example of a previous example. So we can create a data for 1,000 email which are labeled as a spam and a not spam, and machine will find the data which is a spam and a not spam. It will develop the understanding that how we can say that this is a spam and this is not a spam, and based on this data, which is known as a training data, make the decision that upcoming data or the new data is a spam or a not spam. So this part of giving data to the machine is known as a training, and the evaluation of that confidence from the testing data set we are giving. So after that, we will create a one more small data set of 100 emails, which is not labeled as a spam or not spam. And we will given this to the algorithm or machine learning model, and it will tell us that the given data is a spam or a not spam. And this kind of thing is known as a testing. And if we are getting a good result in a testing, then we will go for the commercial production or furthermore. And if we are not getting the appropriate result for the testing, then we will retrain the model, we will modify the data, we will give some more data, or we will manipulate some data so that we can get a good accuracy. So this process is known as a testing in the machine learning. So ultimately, the machine will find the patterns in the training data. Now, you have a question that how machine will find the patterns. So the answer of this question are in upcoming slides. So there are the three kinds of machine learning. So the first kind of machine learning is a supervised machine learning. It is a task-driven machine learning where the answer of the question is given to machine learning, and the machine will learn from the question answer. For example, we will share the question bank, or we will share the study material with the students, and the students learn from that material, and we will supervise them that they are learning properly or not, and then we will take an examination. So same process will followed in a supervised learning. Now, the second machine learning algorithm is an unsupervised learning algorithm. So, unsupervised learning algorithm is purely data driven. So, in unsupervised learning, we will give a lot of data to the machine. We will give a lot of reading material to the students, and based on their learning, the students will come up with answers and a question. So in this task, student will prepare the question, student will prepare the answer, and they will summarize the things. So same way in clustering, we'll give a data only, and based on that data, machine will give us labels and the types that this can be the possibilities in this data. And the third one, and the most recent, where we are making a lot of algorithm in this kind of learning, which is known as a reinforcement learning. So in a reinforcement learning, algorithm learns to react on an environment. So in reinforcement learning is a learning like a child. So when we were the child, we try to touch the hot utensils, hot pots, and from that learning experience, we learned that we don't have to touch the utensils directly. And if we try to taste the utensil, first we have to make a contact for the less than 1 second, or a quick contact to check it is hot or not. So something like that kind of learning will involve in a reinforcement learning. So let us give a closer look of these three kind of learning. So in a supervised learning model, we label the training example, means we will give a question as well as answer. Let's take an example that I have a lot of photographs of cats and a dog. And I want to separate both the photograph, that this photograph is representing cat and this photograph is representing the dog. So what we will do, I will collect 1,000 photos of cat and 1,000 photos of dog, and I will label them that this photo is representing cat, this photo is representing a dog, and it is given to the machine learning algorithm. So this is my data, which is a label training data, and it is given to the machine learning algorithm, and machine learning algorithm will give me a hypothesis or the rules that this kind of images can be called as the dog, and this kind of images can called as a cat. So after getting the hypothesis, I will test my model. So I will give a new image, which is a 2001 image, which is not used previously. And I will give this new image, and it will predict the output from the given image is a cat or it is a dog. So this is supervised learning, when we will give a question as well as answer for the learning purpose to the algorithm. So supervised learning is where you have input variables, which is known as X, and output variables, which are known as Y. And you use an algorithm to learn the mapping function from input to the output. So here, it will machine learning will map output with a function of X, that how the data or inputs is related to the Y. So the goal of the supervised learning is approximate the mapping function so well that whenever we give a new input data, then we can predict the output variable for that particular data. So example of supervised learning is a spam classification, recognition of the handwritten digit, detecting brain tumors from the MRI scans, and identify the fingerprint from the biometric attendance system or a face detection. So these are some of the quick example for the supervised learning, that this image is detecting the face as well as gender involved, which is a male or a female, and it is predicting approximate age of the person. Then iPhone 8, which has a advanced face recognition option, so it can recognize your face layout in a 3D, and it will unlock or lock. And what to do when you have this kind of input? It is quite challenging for the machine learning algorithm, where data is quite similar. Most of the data is quite similar. So we will discuss this kind of problems in a detail in the next upcoming slides. So we can also do predictive analysis using the supervised learning. For example, weather forecast, or a forecast of the share market, or a forecast of the cricket players or a sports players. We can also predict the election results from the previous data, from the previous data collected from the election or a pre-poll surveys, and we can predict the daily forecast for the weather, or we can predict the forecast for the earthquake and the cyclones. So next thing is unsupervised learning. So unsupervised learning is something like this. We will get a training data set. So our training data set, this is a example of the layout of the training data set, that our training data set look like this. And whenever we give this to the machine learning algorithm, then algorithm will define the boundary that data in this region is same, in the second region is same, in the third region is a similar, and this is a fourth region of data is a similar. So whenever you have this kind of 2D data, which have a two dimension x and y, or two features x and y, so we can classify the data in different parts. So more formally, if I say that unsupervised learning is where you only give input data in terms of x, and no corresponding output will be given to your machine learning algorithm, is known as unsupervised learning. The goal of unsupervised learning is to model and underlying the structure and distribution of the data in order to learn more about the data. So we can learn about the data, that what kind of data representation is there. So this is one of the example of unsupervised learning, that this is a one data, and this is a one data, and this is the boundary of the data. Same way for three different clusters. This is a example of supervised learning, that this is a one cluster, two second cluster, and a third cluster. So in this kind of algorithm, we will give the number of cluster, or we will tell the algorithm to find the number of clusters, that how many types of data are available there. And one of the most popular unsupervised learning algorithm is a k-means clustering, where k is the number of cluster you are giving to your machine learning algorithm. So there is a famous quote from the EM Forrester, that spoon feeding is the long run teaches us nothing but the shape of the spoon. So if you do a spoon feeding to the students, to the algorithms, then in the long run, the students or learners will learn the shape of the spoon, but they will not learn other aspect of the learning concepts. So same concept is applies for the machine learning, that in a previous two algorithm, we were a little bit trying the spoon feeding to the algorithms. we will directly spoon feeding by giving a direct data, by giving questions and answers and number of clusters. So there is a one term, there is one kind of learning which is known as a reinforcement learning. So the reinforcement learning will learn from the experience. So in reinforcement learning, we'll learn how to behave successfully to achieve a goal while interacting with the external environment. So in reinforcement learning, agent and environment concept is there. So this is our agent, this is our learner, this is our robot, or this is our machine learning algorithm. So we will introduce our machine learning algorithm to the new environment. And from the environment, machine learning will learn something. And if it will learn good, then we will reward or machine learning algorithm, and we will increase the learning from the learning of t to t plus 1 state. Means we will increase the learning of the machine learning algorithm. So let's try to explore or understand this thing with an example. So we all love the playing the games. So reinforcement learning is something like the playing the game. So here you can see that this is our object or agent, and it can move in all four direction: upwards, downwards, left and right. And whenever agent will meet to the present, it will meet to the present, then it will be rewarded by the one. It will increase the level by the one, or it will give a plus 1 point. And if our agent will meet the truck, or it will clash with a truck, then we will give a -1 reward, or we will reduce the point by one. And this kind of things are trained using the deep learning networks, which we are going to discuss in the next few slides. So let's begin. So before I begin the concept of deep learning or machine learning, so we discuss a lot of about the data sets, or a data, or a training data, or a testing data. So what is the data set and how the data set is appears? So data set is a simply collection of data corresponding to the database table, data matrix, or a collection of the images or a audio or a video, and it can be created manually or can get ready by using the source from a various sites like the kaggle.com, which is a, a website which where you can get a database or a data set for a lot of real-time machine learning problems. So I take an example of two data set. There is a iris flower which has three different category based on the sepal length, sepal width, and petal width. So it has three different species of Vasicolor, Santosa, and Virginica. Similarly, there is one more data set I taken as an example, that audience-based data set, which is quite useful for detecting the age of the person. You can see that this is a 0 to 2 years age. This is a 4 to 6 years, 8 to 12 years, 15 to 20 years, and this image represent the data or images of the 60+ years. So data set are collection of this kind of audio, video, Excel file, or data based on your problem. So there is one more concept which we discuss in a AI aspect, which is a neural language processing, NLP. And NLP is a way for the computer to analyze, understand, and derive meaning from the human language, whatever language we are using in terms of the written or a spoken words, in a smart and a useful way. So machine will learn from our language, over videos, over methods. So it is quietly used for the translation. It is useful for the automatic summary generation, automatic classification of the books, or we can say the movie trailers or movie stories are also created using this machine learning algorithms or NLP algorithm. It is quite useful for the sentimental analysis to measure the feedback of the audience. So it's something like this that we will give a lot of data in terms of the words or speeches, speech or the video, and it will give us something meaningful or some output. So the concept of NLP is also very useful for the humankind, and this is a quite interesting application of machine learning. So most awaited section is here, the concept of deep learning. So in this session, we will discuss about the biological neurons, that how our neuron or our brain will work. We will discuss about the perceptron, which is the replication of artificial neuron, which is a duplication of our part of our brain, which is known as a neuron. And we will create a neural network, as our brain has a 10 raised to 12 billion 10 raised to 12 neurons, so it can be in a billion number of neurons. So perceptron is a single neuron, and in a neural network we will use the multiple perceptron, like shown in this figure, that these are the perceptrons. So we will discuss about the neural network, that how we can use the multiple neurons to create a neural network and try to replicate the ability of a human brain. And then we will discuss about the deep neural network, that how deep we can go, how deeper we can go to copy the human intelligence. And then we will discuss one of the most amazing algorithm in the deep neural network and machine learning, which is a convolutional neural network. And it is a rapidly used algorithm for the image processing, video processing, speech processing, NLP, and a lot of machine learning applications. So let us start this session. So basically, our biological neuron, or the smallest part of our brain, looks like this. So it has a nucleus, it has a cell body, and cell body has a nucleus. And these are particular biological neuron with other neurons. As I told you that we have a 10 raised to 12 billion neurons, and which are connected with each other, so the inputs from the other neurons are taken from the other brain neurons, are taken from this dendrites, and it has a key axon which will give us output from this particular neuron. And this dendrite is connected to the other neurons, which will use to give a output to the other neurons or fire the other neurons. So the working of a neuron is quite complex, and let me give you a quick answer of the question about the biological neurons. If someone asks you any question about the biological neurons or a human brain function, and I will give you a one sentence answer, and the probability for the correction of this answer is 80%, and the answer is God knows. So if anyone give you a question, any question about the biological neuron, give an answer that God knows about this question, and you will be probably 80% correct. You will definitely 80% correct for that particular answer. So our brain uses the extremely large interconnected network of neurons for the information processing. Billions of neurons are in our brain, and inputs from the other neurons are taken by the dendrites, and our nucleus or a cell body will sum all the inputs taken from the dendrites, and it will give a signal, or it will fire, and the firing signal will given to the next neuron for the next processing. And trust me, this process will take a very small amount of a time, even in we cannot measure in a microsecond or a millisecond. It is smaller than that part, and this process will done in this our brain, and this is a totally chemical process of our human brain. So hope you got how our biological brain or biological neuron works. So I am creating a replication of a artificial brain or a artificial neuron, which is known as a perceptron. So this is my center part or a nucleus part of my brain, where I am summing all the given input, and these are my inputs x1 x2 up to xn input. I have n number of inputs, and these are the weights of the particular inputs. So it will give me a weightage of every inputs. It will give me the importance of every inputs, that this input is this much importance is there. And there is an activation function which is similar to the chemical process of a human brain. It will give a firing answer terms of 0 or 1. It will fire the neuron for the next process. So in summarizing the artificial neuron, that we have n number of inputs by x1 to xn, and x1 to xn have a w1 w2 up to wn are the corresponding weightage, and which are the real and the positive values. And this type of configuration is known as a perceptron. And perceptrons adds all the input from the data, and it will separate them into the fired and unfired category. Means that this is a true or false, or this is a spam, or this is a not spam. Like that, it will fire. So when you connect multiple perceptron, then we can make a neural network. So as our human brain have a network of biological neurons, a neural network consists of a number of perceptrons, so which are connected something like this, and each perceptron will fire from the different layer. So this is our input layer of our algorithm, where we will give our input, and there are the hidden layers, and there will be a complex interconnection between these layers, and we will get some output from this whole process of the neural network. So input layer is fed up to each node in the hidden layer, and from there to each node to the output layer. So input is the data is transferred from the input layer to the output layer, and any number of nodes and layer are used to achieve the expected result. You can reduce or increase the number of hidden layers, and we will randomly choose the value of weights. And after the training data set, the value of weight is corrected and fixed. So after the training, the weight values, the value of this function will be available with us, and we will use it for the prediction. So there is one more technical term which is more used in the machine learning, which is known as a convolutional neural network, or a CNN. So in a machine learning, a convolutional neural network is a class of a deep feed-forward artificial neural network that has successfully been applied to analyze our visual imaginary object. So most of the image, speech, or video are processed using this convolutional neural network. So in a convolution neural network, input is mostly image or a video. And as you know that our image is having a three input values, red, green, and a blue, which are the fundamental colors to create any kind of image. So we will do a convolution. And if you have a question that what is the convolution, then convolution is a mathematical term which is similar to the multiplication. I am not going much deeper or much technical at this point, but the convolution is a mathematical process or mathematical formula which will apply to this image, and then it will given to the ReLU. So ReLU will downsample the image, decrease the size of the image, and then it is given to the pooling layer. The pooling layer will take the maximum output. It will pull out the maximum information from the data, and then it is given to the fully connected layer, which is similar to the neural network discussed in a previous slide. And then we will get an output from the softmax function that this is a correct answer, or this is a dog, or this is a cat, or this is a male, or this is a female, or this is a age of the 15 years, or this is the age of the 45 years. So I am not going much deeper or much technical at the moment for the CNN, but the CNN is a quite interesting thing to learn if you want to start with the machine learning, and if you want to start with the deep learning concepts. So now you are the curious that a lot of technical discussion will be there, a lot of technical things we discussed in a previous few slides. But it is said that a sense of curiosity is the nature's original school of the education. So if you are curious about the things, if you are curious about the things, that how these things are happening, how these things are learning, and if you have a question at the point in the mind that where these things are used, where CNN is used, how we can use the CNN, how we can use the neural network, where we can use the artificial neural network, where we can use the neuron, or where we can use the classification, or what kind of classification will be there, then you are a good learner. Or in terms of the machine learning concept, you are the adaptive learner, or you are the adaptive learner, or your learning power is a good in terms of the machine learning algorithm. So let's end up your curiosity of the problems I told you before the few minutes. So the answer of the first application of the machine learning algorithm, which is the recommendation system. Did you seen that whenever you see some video on a YouTube, then you will recommended by the YouTube that this can be a potentially good video for you. So for example, if you are seeing the video on a machine learning or artificial intelligence, Google will recommend the video on the convolutional neural network, or Google will recommend the video on the application of the machine learning. So it is a purely machine learning concept is used. So let's take an example of Netflix. So here we have two users, so, and uh, there is a one female user and one male user, and if they watch the same movie, if they watch the same movie and when see her a new movie, so it will definitely recommend it to the male person about that movie, as they are the similar user. So Netflix or product recommendation on Amazon or Flipkart or online shopping sites work something like this way, that one person buys and there is some similarity in the pattern of purchasing, then the recommendation will be there to the new purchaser. And I will discuss in the next few slides that how companies are gaining that profit up to the 30% or 40% by using these recommendation systems. So a recommendation system or a recommender system tries to make a prediction on a user preference, that what is the preference of the users, and make recommendation we should interest it to the customers. And according to available data, the next bit Netflix gets the 2/3 of its business from these recommendation systems. Google News gets additional 38% of click-through rate from this recommendation system. So whenever you use the Google News, then you will get something that this can be a recommended news. So they are getting 38% of click-through from this recommendation system. And most amazingly, Amazon gets 35% of sales from these recommendation systems. So it is said that a lot of people are buying unnecessary things from e-commerce site. Many times people buy unnecessary things from the online shopping platforms, with the habit of available discount, or with the shopping habits. So it is a magic of this recommendation systems. And you can see that more than uh, third revenue, third part of the revenue of Amazon comes from this kind of recommendation systems. So how does the Google Ads work? So many of you seen the advertisement by the Google when you browse on internet. So the keywords and your interest is collected by the Google. Whatever you are searching or whatever you are browsing is collected by the Google, and it is filtered and blocked or set to the algorithm of the Google. And there is a bidding auction will be there between the advertiser. For example, there are the 10 person who are interested to give advertisement on a particular website, then there will be a bidding, there will be an auction, and who bids the maximum will allocate that ad serving, that ad slot for the advertisement purpose. So that's why whenever we are searching something or we are browsing something on an e-commerce site, immediately we can get advertisement on a Google or advertisement on a Facebook or any other social media, just because of this kind of recommendation systems. Oh, so are you able to see anything in this image? This image represent the English symmetry. The English or Britishers came to the India before the 60, 70 years ago. And before the 200 years ago, when they came to the India, they first came to the city called the Surat, from where I am belonging. And Surat have a beautiful heritage architecture made by the British, which is known as British Cemetery. And I recently visited the British Cemetery. But the problem was that it was almost evening time or a night time, and the sun is set. And I love to collect the photos as I am interested in the image processing. So this is my click of that days, and I tried to give some find some information this from this image. So as you can see that this is a very dark image. You are not able to recognize the object or recognize to the pattern. So I did one magic on this image. So let's reveal. Ah, so this is output from my machine learning algorithm. So you can clearly see that there are so many doors. There are the graves of the Britishers, and it has a beautiful heritage architecture. And there are some trees, and it's a amazing architecture to see. So I was not satisfied from this much information. So I told my machine learning algorithm that give me more information from this algorithm. So it further clarifies the image and give me this image that which contains a lot of more information. As you can see that this is a grave of the Britisher. You can clearly see in this image, which is quite not much clear in the previous image, and it is totally invisible in this image. No one can imagine what is the behind this black part. So I was representing my this work in one conference, and I get a feedback that this is a Photoshop. You can do this kind of thing in a Photoshop. There is no requirement of any kind of machine learning or a complex algorithm. So I given this image to the Photoshop, and this is the result of the Photoshop. I tried a lot of function, and this is the best result what I can get from the Photoshop. You can see that slight improvement in this part, but yet there is a huge difference between the output of the machine learning algorithm and output from the Photoshop or image processing or traditional classical image processing. So this is how beauty of machine learning. This is how machine learning will help you to get the information. So this problem is known as a see in a dark problem. So whenever you want to see in a dark, for example, there is a robbery and you are not able to identify the faces, or you are not able to identify the digit of the number plate of the car from the CCTV footage. This kind of algorithm we will use to do the forensic investigation using the machine learning. So this is the original image. This is output of the first machine learning algorithm, and this is a more improved output of the second machine learning algorithm, and this is the output of the Photoshop. And you can clearly see and you can compare the these four images, and it is clearly visible that machine learning performs far better than any kind of complex image processing software like Photoshop to enhance the images. Second classical problem, which is related to the facial landmark detection. So our face has a lot of information, and that's why we can recognize everyone. We can distinguish the people from the face because the face has a lot of feature. So these are results are taken from my one of my research paper, and these are the 62-point facial landmark detection. So I divided face into the 62 key landmarks, which will denote different part of the face. Like this landmark denotes the outer face body. This is the lips part. These landmarks represent the nose. This is represent the eye part, and this landmarks represent the eyebrows of the particular person. And the the biggest challenge with machine learning is to get an equal performance on the variation of the data. So you can see that this is a quite good image. It has a good lighting condition. Now in this image, the lighting is quite difficult, and it is even difficult to distinguish between hairs and the face part as a human. So this is the output of the particular machine learning algorithm, that you can easily see that in a difficult image condition, and you can also see that the gender and age difference between these two image, and you can see that the results. And this is a third image, which is more complex and difficult, that this is an image of the aged persons who is wearing the cap as well as glasses, and to detect this facial feature of particular person is quite difficult. And this is possible just because of the deep learning algorithm, just because of artificial neurons. And these images are generated using this landmark on the image are generated using the deep learning algorithm. And it is said that if you want to work on the biometrics related to face, if you want to work on the face detection or anything related to facial information, then you have to master this facial landmark detection algorithm. And if you get a quite good result on a facial landmark detection, you can do hundreds of application. You can make 100 of application of the using this information collected from the facial landmarks. So facial landmark detection will use for the many application. As you can see in a movies, we see this kind of animation or special effects. So whenever we are shooting, so we use this kind of facial landmark using the manual points. And if you develop a machine learning algorithm, then you can replace the face by so you don't require this kind of manual facial landmark, adding the manual facial landmark during the shooting, and you can generate this kind of special effect in the movies. So typically it is used for the facial feature detection, it is used for the head pose estimation, it is used for the face morphing, it is used for the virtual makeover. You are quite used to the filters on the Snapchat or many social media applications where this kind of virtual makeover can be possible. So it is just because of facial landmark detection, and it can be used for the face replacement, or it can be used for the eye blink detection, or a person liveliness detection, as a person is alive or dead. We can use this kind of facial landmark detection. So this is an example of augmented reality using the machine learning and facial landmark detection. So this is a original image, and this is a virtual makeover or augmented reality I generated using this the information from this collected facial landmark. Another classical example and a recent trend in a machine learning is a style transfer. So this is a very famous painting of Mona Lisa, and this is a style image which is named as a painting is named as a starry night. And by combining this image, I am generating a Mona Lisa painting with a starry night style. So this is a courtesy of Puckett publication. This image and this algorithm is taken from the Puckett research paper published by the Puckett publications. what else? What else we can do in the face? So we can make people smile. You can change the facial expression of the person. This is the original image, and this is the generated image with a smile. So you can make an artificial smile. You can meet your future self, how you look in the future. So this is the original image, and you can make your image after 20 years, 30 years, 40 years. You can look more younger with the image, and I think this is one of the popular filter available on this Snapchat application. So you can reduce your age by using this kind of filter, or most you can change your gender from male to female. This image courtesy is taken from the NVIDIA research paper developed by the NVIDIA, and algorithm developed by the NVIDIA, and the research paper published by them. So these things can be possible with the face or images using the machine learning algorithm. You can Google about these things, and you will definitely find a lot of more information about how these things are how possible and how these things are happening in the machine learning era. So it is said that what we learn with a pleasure, we never forget. And till now, we were more about technicalities. We discuss about the research. We discuss about a lot of complex algorithm, a lot of technical terms. But what if I will try to explain you with some of the memes? So this is a quite interesting session, and my students love this session. Whenever I take this session, that today we are going to learn this complex machine learning concept with the memes, and students love this session. So what better way to have fun than scrolling some memes? So memes are have become a imperative part of our everyday life. As a proof, we now have more memes every day than good morning wishes from the family group. So learning MLDL from university, not interesting. Online courses, quite interesting. From YouTube, ah, from articles or books, good. And from memes, love the way we are learning. So let's begin. So the first learning from the meme is how are the ML and AI are the different. So this slides is taken from the popular presentation by the Seaman, and according to him, that the difference between machine learning and AI is if it is written in a Python, it is probably a machine learning, and if it is written in a PowerPoint, it probably artificial intelligence. So jokes apart, artificial intelligence is defined as a technology which appears to do something smart, or say mimics the human behavior, and this can be anything from the program software to deep learning models which mimic the human intelligence. Where machine learning is a specific kind of artificial intelligence, but rather than a rule-based approach, the system learns how to do something from the examples rather than being explicitly told what to do, explicitly program. Here we give the data, and machine self-program itself according to the data. 10-year challenge. So before the 10 years, machine learning is called as statics, and now we are calling it machine learning. Ah, I cannot agree, or I cannot say that it is quite same, but yes, both the things are similar. So machine learning is the scientific study of the algorithm and statistical models that computer system use to perform the specific task without using the explicit instruction and relying on the patterns and inference instead of classical programming. So yes, it is an improved version of the statics, but machine learning and statics are quite different. Maths now, in previous slide, I told you that maths is involved, but a lot of questions I received from the ML enthusiasts is that do understanding of maths is required, or it is a prerequisite for the machine learning. Up to the certain extent, it is not required, or the fundamental concept it is required, and this is just because of the available libraries, something like Keras or TensorFlow. We can avoid use of the mathematics, which are all the mathematical things are taken care by these libraries. So you require a little bit maths, but you don't need to have a good score, A or A plus in mathematics, to be able to use the machine learning for your project or be well versed with these models. And many people don't even care about the mathematics behind the ML like I do. I never care much about the mathematics behind the ML. I more give importance to the algorithm. I give more importance to the results instead of maths. So we can make a ML program of in a 5 lines in a 5 minutes using these libraries. So hope it was clear to you that where machine learning and maths are involved. So here 3 robots are discussing that in supervised learning, the robot is complaining that they give me so much to read and taste. They are giving us so much data and so much things to read and testing. So unsupervised learning is answering that me too. I am also getting a lot of data, but at least they will told you the answer of the question. Here I have to create my own answer, my own questions, and I have to solve my problem by my own. And reinforcement learning says that at least you all don't make your own book. I have to create my own book. You receive the book, you will receive the learning material, but in reinforcement learning there is nothing, there is no material will be there. And this meme is a courtesy of Facebook. So here one of the algorithm we discuss in the unsupervised learning is known as a K-means learning, K-means clustering. So application of K-means clustering is quite similar, that you have to classify the data based on the available information. As you can see in this image, the data is classified according to the color. So the clustering means that determining the data, that how closely it is involved, and how we are using the machine learning algorithm. Yeah. So K-means algorithm, it is something like this. So in a clustering means determining how closely related item are to each other and arranging them in a form of the cluster, in a form of the different data of related data items. So K-means algorithm is an iterative algorithm that tries to partition the data set into the K predefined and non-overlapping subgroups. So every subgroup have a different data, and every data point or every data is belong to the only one group. So it can be a cat or dog, or by same way, the image, it can be a blue color or red color or a green color or purple color ball. So this is about the K-means clustering. Now, deep learning. So definitely deep learning is not something like this, but the deep learning is a specific type of machine learning using the technique known as a neural network, which connects the multiple models together to solve the complex problem. Here we use the multiple nodes, multiple neurons to solve a complex problem. So you are quite excited by the previous session and previous slides, and you are planning to start your new journey in the machine learning. So what you require to start, or what you require to solve the real-time problem using the machine learning. So first, I prefer to use a Linux-based OS operating system, as it is open source. So you will get a support from a lot of libraries. You will get a support from a lot of data sets, and a lot of programming language will be available to you. Then you can start with a Python, which is a quite simpler post programming language, and eventually you can move to the R and other complex programming language for the machine learning. And you have to use the different packages or libraries which are used for the machine learning. I will cover few of them in the next slide. And you require one notebook. It can be a Jupyter notebook or something where you can write your code, you can perform your program. And last and most important, you require a lot of data to process, a lot of data to teach, a lot of data to learn. So these are the some of the Python packages or Python libraries. So I handpicked 6 popular and the most important data for libraries for the beginners. So the first one is a pandas. So pandas offers the data structure and operations for the manipulating numerical tables and database file. So you can import your Excel file, CSV file, databases, and a lot of tabular data in the pandas, and you can process that data using this machine learning library. Second one is a NumPy, which is used for the mathematical processing. So most of the mathematical part is taken care by this NumPy library. So it adds support for the large multidimensional arrays and matrices along with a large library of high level mathematical function to operate, and it will take care of all the mathematical things. Then there is a library called as a SciPy, using for the scientific and technical computing for optimization, linear algebra, integration, interpolation, spatial functions, and all complex mathematical processes, mathematical terms will taken care by the SciPy library. And scikit-learn is a popular machine learning library which consists a lot of algorithm from classical regression to the deep learning models, as well as uh, clustering models and supervised and unsupervised learning. So it has a simple and efficient tool for the data mining, analysis, classification, regression, and clustering. And it is designed to work with a NumPy and a SciPy libraries. Next one is a matplotlib. Matplotlib is a plotting library. Then you can visualize your data, you can visualize your images, you can visualize your video, and it is used for the 2D plotting for the quality of figures, and it will give you interactive figures of from your data. And last and most popular for the deep learning concept is known as a TensorFlow, which is developed by the Google. It is an open source software library for the data flow programming across the range of tasks, symbolic mathematical library, also used for the machine learning applications such as the neural network. Most of the deep learning algorithms and most of the image processing algorithm use the TensorFlow backend for the processing. So we are almost going to complete this session. And if I conclude my whole session, so I can conclude my session that MLDN landscape changed rapidly with the smarter things, and people getting more and more familiar and comfortable with the techniques of machine learning and artificial intelligence. To use machine learning in an industrial environment or in real-time application, just make sure that you will keep in a mind this following advisory nugget or up to a certain extent, especially to know your data, that what data you have, know your settings, that what is your business, what is your customer, what is your product, what is the possible outcome of your algorithm, what is the possible outcome of your black box, and know a little bit about the maths or a little bit about the processing of your data. And lastly, know your tools, that what tool you have to use, what algorithm you have to use, what programming language or what mathematical things you have to use. And the problem is not always well defined. Every problem have complexities, and you have to define, design, and transform a messy real-time problem with ML problem. So real-time problems are very complex. Really, they are very complex problem, and you have to convert it to the ML problem and make it more simpler, more familiar to the uh, human being. And last one, and I will give you a challenge, that ML is possible in any field. It can be a commerce, art, science, banking, or whatever field uh, uh, where you are there. Just only one condition is that we have adequate data for the processing. If you have a data, you can do a ML. You can do ML in any field, any field. It can be aesthetics, it can be a research, it can be a science, it can be a chemistry, physics, biology, whatever field it is. Machine learning can be uh, used there. But I have one more bonus thing for you. So we are currently facing a pandemic situation around the world. We have a limited resources. We have a lots of problems which we face, which we never faced previously. And so we have a traditional workflow in this condition that we have a doctors which they will analyze and they will detect. And now they have a lot of burden. Medical professionals or medical researchers have a lot of burden on them, and artificial intelligence or machine learning can help them a lot of. They will solve their problem very easily, and with the help of the medical practitioner and artificial intelligence scientist, we can balance this imbalance which is caused by the COVID-19 around the world. So in a traditional workflow, they have a high pressure and they take a lot of time for the processing. And if we have a artificial intelligence with the traditional method, so our data can be more sensitive and it will take a shorter time. So let me give you an example of this idea. So current situation around the world in a hospital is something like that. We have a limited number of intensive care units or ICUs, and there is a problem that from a general ward, how much patient should shifted to the ICU due to the limited resources, and which patient in ICU also there is a problem that which patients should be on the ventilator and how long. And in a general ward, there is a problem that when this patient will be discharged and which patient can be safely go home. And this image is a courtesy of medical science journal. So we can solve this problem by collecting the data and applying the machine learning. Even many basic machine learning algorithms like linear regression can solve this problem easily. So you can see that in general ward, we can personalize the risk for the every patient. We can take a risk that this person have a 2% of risk, this person have 15%, and this have a 30% of risk of death. And based on this prediction, we can allocate the resources. We can allocate them special units or ICU beds or ventilators. And by this way, we can do these things in a very smaller time using this kind of machine learning algorithm. Ah, but what to do with testing, what to do with a rapid testing. So this is a quite interesting research paper I came across before a week. So these are the MRI images or X-ray images of the COVID-19 patients. So these images are representing the COVID positive patients, and these images are represented by the COVID-19 negative patients. And you can clearly see the difference between these two images, that there is a lot of uh, we can clearly distinguish these two images, that there is a lot of similarity between the multiple images of positive patient and negative patient. And by the help of the image processing or deep learning, we can solve the problem of identifying COVID positive patients and COVID negative patient with the help of this kind of X-ray or MRI scans, as it is easily available and it is not quite utilized nowadays for the due to the COVID pandemic in the hospitals. And I have one last thing for you. So due to the COVID-19 attack, it is a compulsion that we have to wear a mask. And if you get a relaxation from the lockdown, then it is a compulsion to wear a mask. And if you don't wear a mask, there will be someone like some machine learning enthusiast like me will be there to detect you. And definitely many governments are using this kind of algorithm to detect and find the people punish the people which we are not following the rules, and which can be a potential spreader of this pandemic disease. So this is be aware, and maybe some machine learning enthusiast is there to solve the problem for this pandemic situation. So that's all from my side. Thank you so much for your patience, for your participation, and your questions are most welcome. You can type your question uh, in the comments, and I will try to answer the question. If you have any question, you can give in a comment. Can you repeat?
How can we choose a specific model in machine learning?
This is a quite interesting question, and most of you have the question that how we can choose the specific model for the machine learning. So first, to select before the selecting any model, first you have to get information about your data. So
Mm-hmm.
you have to information about the data, that how much parameter your data is having, how much information is having, what is the possible outcome of your algorithm, what is the complexity of your data. For example, if you have a data in form of the images or videos, you can choose the convolutional neural network or a feed forward neural network. If you have a
Mm-hmm.
data which is a linear, or which is in terms of the tabular form, then you can use the regression algorithm. And if you want to segregate the data, then you can use the clustering algorithm. So based on your data, based on your problem, you can select your machine learning algorithm.
Okay. So I have one more question regarding recommendation engine.
Yeah.
Suppose I am a new user, so how the engine tries to recommend me what kind of products or searches will be useful or recommended by me?
Uh, as a new user, the recommendation system get your location, your IP address, you are registering for the particular website or social media, then you will specify your date of birth, your your location. So based on that, recommendation system take that parameter. If you are a
Mhm.
quite new user for the system.
Okay.
Next one, please. Next one, please, sir.
Hello.
Yes,
Shivani?
Shivani.
Yes, sir. Sir, as you have told us that there are many libraries in Python which we can include before processing the things, right? So, do we have any such library to process the audio dataset?
Yeah, there are so many libraries. There is a one library which will give you a spectrogram of the audio. I think as far as I have a knowledge about audio, there are the three key aspects: frequency of audio, spectrogram of the audio, and the volume level, or what we can say intensity of the audio. So for the audio, there are so many libraries are available, and one of the library which is known as a spectrum or a spectrograph, which is quite useful for the audio processing purpose.
Okay, fine. So, sir, is it possible that from an audio dataset we can find out the gender and the age of any kind of speaker that is speaking on that audio?
Definitely, because every person have a different frequency, different amplitude. You can notice that by getting age, or speaking speed will little bit reduce, or audio frequency will little bit change, and our tone will be changed. So by taking this parameter in consideration, we can definitely detect the gender of the person, or even from the language we can detect that this person is belong to the particular location. For example, this person is belonging to the Southeast Asia, or this person is belonging to the Europe, or this person is belonging to the America, or this person is belonging to the New Zealand. Just because of the tone or what we are using in speaking the language. So it can be quite possible for audio processing, and there is a lot of scope for that kind of problems to solve that kind of problem.
Okay. Thank you, sir.
Next one, please, sir. Most welcome.
Ishan?
Yes, sir. So I'm having one question.
Yeah, sure.
So, like, I wanted to know, like, where to use the regression in the projects. Like, regression now, some algorithms like polynomial regression, multilinear regression, linear regression will come under regression type supervised learning, right? So, when to
Yeah.
use, so like, because logistic we can use in classification because it is considered to be a classification algorithm, although it is a logistic regression. But other algorithms are where to use. That's the thing.
Yeah. So if you have a smaller dimension problem, for example, I want to predict the price of a house using the available parameters, that what is the number of BHK, and I have two parameters, the BHK and carpet area of the house. So based on these two parameters, I can detect the price of house. So by
Okay.
this kind of simple problem, we can use the linear regression. Now, if we have a complex problem, like recommendation system, that there are a lot of problems. There are gender of the person, area of the person, and a lot of parameters, buying habit, income criteria, native places. So at that point, we have multiple parameters, and our algorithm become a little bit more complex. So for that purpose, we will use polynomial regression or complex regression algorithms.
Yeah, sir, and one more question was there. Like, there are some variants of regression, like, sir, for lasso regression is there and ridge regression. So when those can be implemented, like variants, they are called as variants of regression, the linear
Yeah.
regression.
So basically, regression is a quite simple term that we are predicting the future. So based on the problem complexity and data, we are generally selecting. So many times this kind of additional regression terms which are used, and this kind of terms generally used for the batting prediction of performance of the particular player in a cricket match or in a football match. So that kind of problems, generally this kind of dedicated regression algorithms are used.
To some other places now, in so like large data sets, when we have to do some like time series forecasting and those type of algorithms like SARIMA and ARIMA. So like how we come to know about the prediction, because like in the like with respect to SARIMA and SARIMA with extraneous regressors, the more or less prediction looks to be the same. Like what can we make out with the difference with that, those type of algorithms in time series forecasting?
You can use the ensemble method, bagging, boosting, and bagging, boosting, and a random forest method for that kind of complex problem, where you can combine multiple regression or multiple techniques to solve the problems effectively.
Mm-hmm.
So I suggest you, for the time series forecasting, go for the ensemble model for the base result, and I'm pretty sure you will get quite effective result using the ensemble methods.
Okay, sir. So like random forest or decision tree classifier
Yeah.
or extra trees boosting like that.
Bagging, boosting, ADA boost. There are so many ensemble
Random.
method.
Okay.
Bagging, boosting, ADA boost. You can use any kind of thing algorithm. You have to give a try, and ultimately it is a trying testing and trying process, trial and error process, that
Mhm.
on which algorithm over data is getting a good performance. And the best part for the machine learning is to know your data, as I include that know your data first. So
Mhm.
if you know your data, you will definitely get information from your data that which algorithm will give you a quite uh, uh, answer or a quite good performance for your machine learning algorithm.
Okay, sir.
Mr. Afroz?
Yes, sir.
Actually, I want to like ask you, like you have shown that Python we use for machine learning, but are there any other tools? Like when we go to cloud, like in AWS or Azure, there are so many tools. So what tools can be used for this? And another one thing is Hadoop. Can you tell me about this?
Definitely. So basically, Python is a basic programming language. You can do the machine learning in the C also. You can do a machine learning in a simple Excel also. You can do a machine learning in a R programming language also. And there are definitely a lot of language, programming language for the machine learning purpose. Now your question about Hadoop. So Hadoop is a specifically designed the set of tools for the big data analysis, where we have a lot of data and we have to analyze the data for the machine learning. So Hadoop is mostly used for the data processing, data analyzing, and Python and TensorFlow is mostly used for the creation of the model, or you can say to train the model we use the Python, and to store, process, and manipulate data we use the data processing systems like Hadoop, Azure, and many more. Next one, please.
Ashraf, please.
Hello, sir.
Yeah,
Hello, sir.
yeah.
Most of my questions has been answered, but my main question is that we have most advantages of AI, but don't we have the disadvantages?
What are the disadvantages of AI?
Yeah.
Yeah, so first and most discussed disadvantages is, do I lose my job because of AI? This is the first and most discussed question, and the answer of this question is no. You will not lose your job just because of AI, but it will create a lot of job opportunities in terms of the collecting data, processing data, predicting data. But the unskilled workers, or those who are not changing their self, they're changing their technology. For example, some people are stuck with the classical programming or traditional programming. There can be a problem for that kind of people, as we are more evolving with the data science and machine learning related things. There are quite few problems, like she told that there is a problem with the data privacy, as we are sharing a lot of data with companies, a lot of data online. Then there can be an issue with the data, and you may aware about the recent data breach of Facebook, that they shared some data for the political purpose. So that can be a possible advantages of uh, 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 machine learning. That can be a possible disadvantages of the machine learning or AI. But ultimately it is a more advantageous compared to the disadvantages. And if you use machine learning with care, if you concern about your privacy, if you concern about your online presence, if you concern about your data, then there will be no problem or no disadvantages for you with regards of the machine learning and AI.
Okay, thanks.
Most welcome.
Yogesh, sir.
Yeah.
So we have a time limit and we are ending this session. If you have any more question, you can drop a mail, and I am requesting Yogesh sir to share final concluding remarks for this session. Thank you so much for your participation.
Yeah, thank you very much, Bassar sir. Sorry I could not be there at the beginning due to some other engagement. But yeah, I joined you in between, and really, it was really insightful on that topic. I feel that I missed it, but definitely I will ensure that I will cover that missed part on the YouTube when Dinesh sir will put it. Uh, I'm really great to see the different applications that you have implemented about the image improvement in the dark, and the ideas that you shared, that we can use it even in the current situation of COVID-19. So it is really important for us to understand that where can AI be used or machine learning be used? Because again, we know that each and everything cannot be done, but exactly we should know what can be done, and that you made it much